Okay.
So, Paradata, metadata, and data for the 3D documentation in cultural heritage. Let's clarify the field here and what's all about and what we have to do. Now, that's, as I mentioned 2 days ago, the first approach within the OERICA 3D initiative for the digital documentation of tangible. We are tackling here tangible objects. And those are the museum objects, monuments, and sites. Yeah? So, okay. It's all about Paradata. And of course, the point clouds followed by the 3D modeling, or as we hear it very often, or see it in the literature, scan to beam, if it's about tangible objects. Yeah, BIM, Building Information Modeling System. The data sets, once when we have data, we need to store them by following some format. And of course, the metadata, yeah, the information which describes the data. Now, information. Let's clarify it. We have two disciplines, the information science as well as the computer science. Both disciplines understand under information what? The paradata and metadata. And that's it. We need to clarify it once forever. When we talk about information, then it's paradata and metadata and nothing else. But when we talk about data, then it's something totally different. And that's the 2D, that's the 3D. And under 2D, we have the images, not only geometry, yeah? We have texture, the so-called texture, and so on and so on. So now, we can go more in detail so far as this slide is concerned, but not now. Let's move forward. Now, I want to show to you a small video. You see here the title, The Problem So Far as Understanding Paradata Concern. That's another one case study, which is coming via OERICA 3D to be harvested in European. This case study and the video clip, as you will go to see it now here, experience it now. It's live since a couple of hours. It's a good example also for the under preparation video clip of OERICA 3D. Yeah? So now let's go and see what's all about. It was a digital documentation of the Ibrahim Aga Mosque in Limassol. And the an area which is going to be very soon further developed by the municipality. It's the square of peace and cooperation among the two communities in Cyprus. This is the area here. It's going to be further developed. And for that, we need what? Data, drawings, planning. So here, voila, we had to scan, and we scanned here. You see the monument, the points of references in the modern one way, how from 2 images, from 3 images, the computer software is finding common points so that these images that you see there can be matched together. And if you match them, you create, according to the triangulation theorem, what? 3D points. Now, a nice image animation here of UAV flying around, creating images, and the system in the center to do what? Structure for motion calculation for the 3D points. Now, the meshing is coming from all these point clouds, And then at the end, slowly, you see what? The 3D here, as you see it here. Yeah? These are data, what you see here. But this, what you saw earlier in the animation, that was all about Paradata. Yeah? So now, that was with the UAV. Now we have the terrestrial laser scanner. Okay? Because we combine the data of a UAV and of a laser scanner together. And that's the survey. That was the 3D documentation, 3D digital documentation. You see the scanner here, you see then on the other side, the 360 degree images, the different positions, of course, yeah? And the result on the other side, 28 positions, 120 million of points. And please have in mind, all this information that you saw up to now is nowhere to be found by all the up to now 3D objects available under European. Okay? So, and this what you saw earlier was interior, the interior, now the exterior, that's the church, different positions. If you scan them, of course, all together, again, 180 million points. Voila, the exterior. And you have to merge all together. And of course, to create what at the end of the day, and that's all about to increase the use and reuse. Now we're talking about data, okay? And voila, this is a CAD system, computer-aided design. Yeah, the different columns for the bell tower, different kind of materials now. All this is important information. Yeah, it's a bell tower consisting of different materials. That's why we are using a building information modeling system to do what? To link all this semantic information together. Geometry plus materials. We're going to talk later about that. So, bell belongs to the monument. Monument as such, shading and texturing. Of course, the mosque is only a distance of 200 meters among the two monuments. Have in mind, Limassol was or is still a bicommunal city, hosting both communities together. This is the scanning of the interior. And this is again, that's data, but it's all about how I collected the data. Yeah. And now the modeling, the different elements of the 3D object of the mosque. The interior. That's 1-to-1, yeah? That's what exists over there in dimensions and so on. Except the avatar over there. So, their use in virtual reality as Europeana would like to have it. Of course, now we have the raw material after the pre-processing, the meshed what? Point cloud, where a user can do whatever would like to do. That's the reason why 2 days ago I said some of the users would like to have what? The raw material in place and not only the 3D model. Why? because the 3D model is not good enough for me as an architect. I want to create the model according to my requirements or the requirements of whoever likes to have a 3D model out of that. Yeah? So the two monuments, the square, which is going to be totally reformed in the next 1-2 years with a very big investment from the municipality. And that was a joint project with the municipality, the second joint project with the municipality. Now, let's go to the Paradata again. That was a very good one example to show to you and illustrate the power of information and data, distinguish between that. Now, the Lambus abode that you know very well, relevant information about that. It is in the final report of the study on the pages 54 to 61. Yeah? So, and this is what you see here. Those are the images which you see. You cannot read them, but anyway, it doesn't matter. So, all those are extremely important. I want to go to the first one, which is very important. Stakeholder requirements. Stakeholder requirements. And there is where it starts. Description of the object, tangible object. Yeah. And then we have to define, is it movable or non-immovable? Please tell me which one object in Europeana, according to the whatever metadata they have used on that time to describe it, is using movable or immovable. Then the name, the clear name, the reference, the description, short description, the dimension, the weight, the location, IPR issues so far as the object as such concerned, not the digital record, the object. Then if it's touchable object or if it's a portable object. And then, of course, the stakeholder requirements for whom? For the one who is taking over the data acquisition, the timing, and all these kind of things. Yeah. So by saying this, I will move forward. Just I don't want to, because we have so many other things to show. It's just only to show to you the content is there. Please read it carefully. It's very, very, very helpful. And if you don't understand something there, please let us know. But it's in such detail described so that everybody can understand it. Okay. So now the Lambusa fishing vessel. The mayor jumped over to us between the mayor office and our lab, or here where we stay. It's 150-meter distance between my office and his office. Is just only 7-meter distance. Yeah. So we know each other. We're very good friends, and we are helping each other. So, and he jumped over to us. He said, "Here is the boat. We want. There is a voice to totally demolish it. There is a voice on the council of the municipality to preserve, and probably we're going to preserve, but we want to keep a digital copy of that." And you know the story. To keep it short, we did the digitization and we move forward. Now, stakeholder requirements. All this, it has to do with the quality of the final results. You cannot present something and say, this is my 3D model without taking into account what? The stakeholders' requirements on that time of the digitization. And of course, the conditions under which the object has been digitized and how it has been digitized, what the kind of instruments have been used, from whom it has been used, where it has been used, under which conditions, and so on. All this is Paradata. It's the missing information up to now since the creation of Europeana. And now it's the new era with our project based on the study to change this fashion, this tradition. So we need that, Paradata. And here is voila. Also, we have the object, materials. Please let me know where the materials have to be defined in the EDM or in any other metadata structure. Metadata schema, data structure is us, data, the computer scientists are saying, the humanists are saying schema. So materials, location, where was the object when it has been digitized? Yeah. So the dimensions and so on, and so on, and so on. Who were those who digitized them? Were professional or not professional? Had difficulties or they didn't have difficulties? Under which environmental or weather conditions they carried out the documentation? Yeah. So, and then of course you see here the accuracy, the different kind of formats of the object, but please pay attention. E57, what is that? E57, those are the points, the 3D points coming out of the laser scan, coming out from the SFM algorithm, from the pre-processing, let's say in this way, and after the data are clean. E57, this is the format that all the manufacturers of laser scanners or data acquisition devices understand. This is what they give out. This is the first one format. E57 means XYZ. Finish. Now, with this E57, do we need it in Europeana or we don't need it? This is original data. We need it. It has to be there. Why? Because during the time of my 3D modeling, I used a hardware and the software in the time of 2020, let's say 3 or 2024. But if someone finds this original data here, original sets, could be in 2027, is going to use a better hardware, a better software to create, of course, much better results, 3D models, and even in formats which are going to be more in the fashion of that time in the future. Have that always in mind. We are working not for today, but for the future, for the use and reuse, for the increase of the number of users. Okay? Have that always in mind. And to be sure that we can prove that this original data, this E57, has been created using high quality of infrastructure devices. That's why we keep also what? A record of the information or the data describing the devices with which we scan the object, as you saw earlier with the nice demonstration with the UAV as well with the laser scan. Okay, so the team you see here, I don't want to repeat again. Environment, under which environmental conditions, and please let us distinguish environment with weather conditions, two different data sets which are extremely important. Okay, and we need to separate them always. We need to keep them because they have influence on the quality of the data. So you see here the weather, yeah, the environmental, yes, and of course here the environmental data here. Here are the weather. Okay, sorry, it's a mistake here. Environmental conditions. Okay, nevertheless. So the same also here with the UAV and the Paradata with the software and the hardware. We are giving also a report which software, which hardware has been used. We need them. We need to describe exactly how we created our data. Otherwise, we are not in the position to certify our data. Yeah. and here, voila, all together. Yeah. For the UAV, for the camera, camera has been used by the human. Yeah. The laser scanner again, all the technical specifications, even some settings on the scanner from the display of the scanner directly to download from the device and include them in the Paradata. Yeah. So, and you see here the photogrammetry software. How is the software? The raw data. And you see at the beginning, that's a chaotic situation. Nevertheless, it shows the environment. It shows under which difficult conditions. You see, it was very short distance between the two boats there where the Lambusa was located. If someone who understands about data acquisition and sees that, the person can get the message. Okay. Which is totally different. Yeah, of course. Okay, the registration tool, how the data have been registered, which parameters we have used, then the different positions of the laser scanner, proving that the data are of high quality. And of course, you see here per image, the different parameters, hardware and software of the data acquisition device. Yeah, please pay attention. All these, we're talking now about Paradata. Yeah. So, and you see here the boat, what we had as an input, yeah, to scan. And of course, the follow-up, and we have between this structure here and this structure here, thousands of other images to show to you step by step how from the old one we came to the new one boat. So now the pre-processing again, the same. Now it has been mentioned also last time by Nazio, cloud processing. Yeah, we are moving now from the desktops, from the laptops, from the tablets to the cloud. We are not working anymore in our office, or we are in the office or somewhere, I don't know where, but the cloud is computing. And that's extremely important to know also the specifications of the system, calculating, creating our data results. Yeah. So, and then of course the different software in place, exactly the same way as it was with the nice video presentation. How many faces have been created here? You see in millions. Yeah, the mesh geometry again, as you saw it earlier with the other one example. Point sampling of mesh, 5 million points, because you don't need all the points. You can collect, you can select, collect, and so on, and move forward. And that's here, you know, the mastership. You need here experts, but you have to prove that you had the experts in place by do what? Recording in your Paradata who did this job. Yeah. Now, how this reconstruction has been established, how it has been created, the methodology as such, it needs to be described, yeah, so that the experts will be convinced that the final results that you are offering to them are of high quality. Otherwise, there is no sense. We are continuing the same old tradition for the future, yeah. So, and of course, all the different details here, I will, of course, here, this is now the language that a naval engineer understands. This is, at the end of the day, that the naval engineer would like to have. But the naval engineer, to be able to judge and say, aha, these data are of high quality, needs all the previous information which we mentioned. Information, yeah? Paradata. Without that, you can prove whatever you want with this here. Yeah? Okay. And now the nice video that you already know, of course, as an overview, just to fly about that.
I can skip the.
Yes. We can skip even the video. We can go to the final part.
Yeah, we'll go.
And you see, okay, it was short. There are the materials. Here, the materials. Go to the materials. We need to show the materials. I think they're coming later. The materials are coming later. Yeah, later. Yes, here. It's a very important information this year. The boat consists of what? Yeah, some materials. And these materials are under which conditions? Yeah, when you digitize that. So which object? Please search all the whatever thousands of objects and tell me one object under Europeana where you will find this information. This information is not metadata. This is paradata. But you have to prove that this information has been captured by using which methods, so that you prove that you are correct and your data are of high quality. Okay? Let's skip.
Yeah.
And now, of course, the different kind of software which has been used, and we are coming to the 3D model data export formats from Rhino. Why? And it was also someone from the partners asked me last time in Brazil, why you didn't use Revit and you use Rhino for the Lambusa boat? Very good, excellent. That's all about, because Rhino, only Rhino can do the job for objects like the boat. Is a system which is created to handle freeform surfaces. Freeform surfaces are any possible surfaces in the world that you can imagine, free of any kind of form. So those in mathematics are the so-called non-uniform rational splines, the so-called, with the acronym NURBS. Revit is a prismatic, is a software which handles prismatic geometrical object, a square, yeah, a triangle, or even very simple, a cylinder, yeah, a pyramid, and so on. Prismatic objects, but not freeform surfaces. That's the difference. So now, it's the term of our friend Panayotis to continue with the Rhino 7 3D models.
Yes.
You know, we exported our data.
Yeah, this is the list of the variety of 3D formats that you can export from, for example, from Rhino. Okay, we discussed about the Rhino file, but this is, as you can see in red square rectangle, you see the OBJ that we can export as a standard for 3D model, but also we can export the STL file format, which is specifically used for digital fabrication. Okay, this is the metadata of the Lambusa fishing trawler. I don't want to say much about this, but I wanted to show you the metadata as well that we already input for this case study. But also you can see the format as well that we discussed.
Identifier. Why there is no identifier? Is the first time that this object has been created digitally. We are waiting from the owner of the object, from the stakeholder, who is what? The municipality, to give us the identifier. And this identifier is going to be what? The same as in the archive, whatever where they have their box files and so on, all the information available. There is only one fisher boat, and that's, you know, Very simple here. Now,
Yeah, and now we can also see the another case study, which is a clay plate from the collection of the Cypriot artifacts from Medelhavsmuseet in Sweden. Okay, again, some information about the Paradata. And what I want to focus now is again the formats that we have. Also, the accuracy is higher because it's smaller objects, so we wanted much more accuracy. But you can see the formats, E57 for the point cloud, OBJ, STL, but also the MTL and the JPEG regarding the texture. And I will explain in the next slides some more information about this. But also you can see the ISO standards related to those formats mentioned. Okay, this slide shows how the raw data is processed, the images, and the acquisition of 498 images, point cloud data, then the mesh geometry without the texture, and then you can see the mesh geometry with the texture. So using those images, you can create the texture as well.
and this is the
yeah, on the camera you can see
the copy,
3D printing,
the duplication of that out of the STL that we created for that project. So,
yeah. And from Aegis of Metashape, which is the software where the photogrammetry was done for this artifact, you can export the point cloud, the E57 mentioned previously, but there's also a variety of other formats that you can see. For example, LAS, PLY, stand for PLY, which is you can get the point cloud. And on the right now you can see the different parameters that you can put to have a color, but also the wavefront OBJ format that you could export from Aegis of Metashape. And now you can see the export parameters, but also you see the export of the texture, which is in JPEG format.
and please pay attention which options are activated here before we push the button OK. Yeah, before we start the creation of the object. It's extremely important to have all this information again, yeah, in place so that the experts can understand what the kind of quality of data they have in front of them in order to use and reuse them. So simple as it is.
Yeah, and also you can have other formats as well, STL, PLY. Okay, and this is the data that you get on your computer. Here are the 3 files that are generated while you export them.
And it's extremely important here to pay attention. Now, because in the last meeting, we tried to set up a system how Paradata can be linked to metadata. And voila, here, because with this here, we linked it even directly to the data. Very simple way on how we define the name. See here, name, plate A.019.013. This A.019.013, do you know what it is? Is the number not coming from us? No. Is the number given by the museologist, by the archivist of the museum in Sweden. Yes. And voila, we have even here in the name, what? The direct link to the object, which is located somewhere else.
Yeah, and as a and on our visualizer, we can see the OBJ 3D, but also when you open the OBJ, you see this, but also you can see the if you open the JPEG file, you see the UV texture mapping for the object. And also, when you open the MTL as a text, you can see the several parameters. I don't know, Drew, if you want to say something regarding
Yes.
this.
Hello. So material files. So a material file is a separate file to the object file. And the easiest way to think about this is the object file is the geometry. So if we think we have a lovely wall, which has a picture of the Mona Lisa on it, material, we have a accompanying material file, which points to all of the different image files that we're going to use to create the picture on the wall of the Mona Lisa. So we have our image files, which will tell us what the textures are, whether they're specular, so if they've got shiny reflection, or if they're rough, if they've got color, or if there's depth even into it, we can apply all those. But the material file tells us how to do the painting. If we don't have material file, then we just end up with a gray geometry. And if we don't have the texture files, it'll tell us that they're missing, so that we know what should be there. Probably the easiest way to do it. It's a manifest of the additional files that we need to interpolate information into the model. Is that okay?
Yeah. Okay, thank you, Drew. I will continue with the next slide. So here on the next slide, you can see you can actually get it from your QR code. This is the Excel, which includes all the 3D formats within the VG study. I think it's 120 formats. You can have a look, and also within those formats, you have the description and the corresponding standard for each format.
And the link and all this kind of thing.
Yeah, you can download it from the QR code.
And the reason why I asked at the beginning if Europeana is with us is because under the Competence Center, they tried initiative, they tried to reinvent the wheel by creating another one catalog, more or less up to 97% overlapping with this what you see here. Yeah, it is one out of the 14 attachments of the report. Please have a look. Yes. Scan that here and you will go directly to the Excel file.
Okay, so here the information, the metadata information for this specific artifact.
And please pay attention on the title.
Yeah, the
this
ID.
Is the ID. There is where Nazio. We have the link. Paradata, metadata, data, linked together only by one, only one. And there is no second item with the same name.
Yeah. Okay. The metadata, and also you see the format, OBJ, MTL, JPEG, and STL.
Yes, just a second here. This what we now want to create is one object, you see it here, which is available from the software, the hardware, which has been used to digitize it. Pay attention, first to digitize. Secondly, to create the 3D models, okay, as it has been described in the Paradata, in the 4 different formats, which means we have 4 different files, separated files, describing the same object, okay, under one inscription. Please pay attention on the one inscription. So this data, this object has to go to Europeana with 4 files ready, plus There is another one which is not here because we haven't yet got the answer, official answer from Sweden, is the E57 format file with the 3D points, the original 3D points. If we get their okay green light, then it's going to be 5 files they are available. Okay, no 5 inscriptions, no 5, let's say, different in brackets objects describing one and the same entity.
Okay.
Yes.
Okay. And also you can find this information from the Europeana website. You can also scan the QR code that you can see on your left and access the object. But it leads you also to Apsida, where you can download the 3D model as well. They haven't put it on the 3D model. I think it's not available in Europeana. You need to go to the Apsida, which is from our university.
It's an STL where you will find all the data.
No, it's
there,
the OBJ with the texture. And,
but it's the STL,
there,
including all this data together. But please pay attention. This object is now harvested to Europeana via the national aggregator because we wanted to show some results to the Deputy Ministry of Culture. This object is dedicated to be harvested in Europeana via Oerica 3D, and we will get it out from the national aggregator. If something goes wrong by Oerica 3D, we are going to keep it for the 14th of May by the national aggregator. If everything goes well, oh, well, okay, we will keep the record of Oerica 3D live, and we will exclude the national aggregator one. We will erase, national aggregator will be just turned off. Yes.
Okay. And finally, we can also mention an upcoming webinar that we have on Monday, 8th of April, from 2 to 5. Is it Cyprus time? You use the Brussels time?
It's CT.
CT, okay, CT time.
This is extremely important. This is the webinar that we announced, okay? And please have a look here on the background. Mnemosini, which means Annonella memory twin. And for that, Paradata, Metadata, and data for 3D acquisition in cultural heritage.
Yep.
That's
and
it.
the QR code to if you want to register to this webinar. And thank you for your attention. Okay, started recording. Okay, sorry for the